All right, so let's go ahead and talk about solving absolute value inequalities. So we just talked about solving absolute value equations, which is pretty similar. All right, we had to set up two related equations when we did that, right? Because the expression inside the absolute value bar could have been positive, but it also could have been negative, and so we had to account for both possibilities there. So similarly with absolute value inequalities, we're going to set up two related inequalities. Now there will be some sign flipping that happens, but we'll cross that bridge when we come to it. So some steps for solving absolute value inequalities are going to be very similar to when we were solving equations. So we're going to isolate the absolute value expression if necessary. Then we're going to set up two related inequalities, and we're going to have to flip the direction of the sign and negate the right-hand side of the inequality for the second one. So remember, with inequalities, if you're multiplying or dividing by a negative number, you have to change the direction of the sign as well. All right, then we will solve the inequalities, check our solutions. That is a bit of an optional step, and let's graph our solution sets because it's so fun to do when we have inequalities. All right, so first one, just kind of getting our feet wet. We're not really there's not much solving going on in this one. So if I have the absolute value of x is greater than 4, the two related inequalities are going to be that x is greater than 4 and x is less than, flipping the sign, negative 4. So I had to flip the sign and negate the 4. All right, so in terms of like checking our work, well, we could think what would happen if I plugged in a number that is, thinking about this one, bigger than 4. So let's say I plugged in 5. Does that work? Well, yeah, it does. So that one's good. All right, and then over here, same thing, we're going back to this original expression right here, but now I'm looking for an x value smaller than negative 4. So let's go with negative 7. If I plug in negative 7, absolute value of negative 7, that's going to be 7, which is greater than 4, also works, right? So that is how we could go about checking, right? But we have a whole range of values that could make this true now, so we can't check all of them. So for graphing, I'm going to go ahead and number my number line, starting at negative 5. I wrote negative 2 twice. So silly. All right. All right, so we're going to have an open circle at negative 4, getting smaller. Open circle at positive 4, getting larger. All right, now we're going to go ahead and actually have some solving to do here in example 2. So our absolute value bar, it's already isolated, right? Nothing else happening to our absolute value expression. So we can go ahead and set up our related inequalities. So if x minus 1 is less than or equal to 3, our other one will be x minus 1 is greater than or equal to negative 3 because I'm flipping my sign. All right, so now we're going to go ahead and solve these separately. So I'm going to add 1 to both sides here to get x is less than or equal to 4. Over here, we'll add 1 to both sides and we'll get x is greater than or equal to negative 2. All right, so what's going on here is I'm going to have to number line, I'll start at -5 again. And we'll have a closed circle at 4. We want them to be smaller than that. We'll have a closed circle at -2, and we want them to be bigger than that. So what you'll notice is that we actually have like overlap here. So how we go about graphing these is, let me redraw my closed circle here, just connect them like so. So it kind of looks like a little line segment. And this is what previously, when we were talking about, these are compound inequalities. So previously you might have written it kind of like a sandwich. So -2 less than or equal to x, which is less than or equal to 4. Those are going to be our solutions. Up here, we should have said that x is greater than 4 or x is less than 4, and that's how you'd write that as compound inequality. So or always has the arrows pointing away from each other, and looks more like a line segment that's been connected. All right, example 3. Again, no need to do any isolating. We'll just jump into the setup. Got 2x plus 5 is greater than 7, where 2x plus 5 is less than -7. Go ahead and divide everything by 2. You get x is greater than 1. Over here, I'll have 2x is less than -12. Divide everything by 2. I'll have x is less than -6. Alright, so for this graph, I'm going to start at -8. I can fit more of my graph on here. But x is smaller than -6 and bigger than 1. Both of these, right, are not inclusive, and so you have open circles at those endpoints. All right, just a couple more examples, guys, then we'll be done. So, this, by the way, should have written 4, box those up. Oh no. All right, so we've got this one. We do have to do some isolating first, so I'll subtract 1 from both sides. We'll get x minus 2, the absolute value of x minus 2 is greater than 3. And why don't you go ahead and try this one out? So go ahead, set up your related equations, graph it, and then come back and check your work. Did you actually pause? Actually pause the video, try this one out. Alright, so we are going to do x minus 2 greater than 3, x minus 2 less than -3. So we'll get x that's greater than 5, or x is less than -1. And let's see, I'll start this at -3 so that we can see more of what's going on. Open circle at 5, open circle at -1, pointing away. Alright, last two. We will divide both sides by 3. So I've got x plus 1. The absolute value of that is less than 4. So if x plus 1 is less than 4, and x plus 1 is greater than -4, Alright, so this means that x is less than 3, x is greater than or equal to -5. And I'll start graphing again. Let's go. -6. Alright, so we got a closed circle at 3, closed circle at -5, pointing towards each other. What am I doing here, folks? Like so. A little number line. And the very last one, there's a lot of work to isolate this absolute value expression. Divide by 2. The absolute value of x plus 5 is greater than or equal to 2. So if x plus 5 is greater than or equal to 2, x plus 5 is less than or equal to -2. So we'll end up with x is greater than or equal to -3. X is less than or equal to -7. I realized I didn't rewrite that one. Here. So I'm going to go up really quick and rewrite this. One as a compound inequality. Alright. This one I'm going to write 4. And let's label this -9, -8. Alright, so we've got a closed circle at -3, closed circle at -7, pointing away from each other. Alright, there you go, folks.